Hello, everyone. Uh, my name is Ben Lewis. I'm with the Center for Geographic Analysis. And I want to start by thanking OmniSci for inviting us to participate in this virtual summit. And I hope that all of you and your families are healthy. These are interesting times, definitely, and pretty unpredictable. And in this environment, I think data is becoming more important perhaps than ever. I might even suggest that data which is reference to time and space is some of the most exciting right now in the context of COVID-19 research. So, trying to answer questions such as where are cases in relation to hospital capacity, cases in relation to loosening of regulations, looking locally, moving out to global perspectives. How has human mobility changed? Where has it changed in relation to changes in regulations? Where hasn't it changed? And so on. All kinds of really important and timely questions that can be asked of large streaming data sets, of which there are now many. So these are super important times for data scientists who deal with such data. And it turns out OmniSci, with its strong spatial and temporal visualization and analytic capabilities, is becoming especially relevant as a tool in the overall data science toolbox. And so today we present work we've started at Harvard in order to make geospatial big data analysis capabilities available across the Harvard research community. So the Center for Geographic Analysis at Harvard has been formally collaborating with OmniSci for several years. Informally, it's been collaborating for much longer. One could even argue that the earliest days of OmniSci were at CGA back in 2012 when Harvard student Todd Mostock and I started brainstorming exploration tools for big data, and Todd developed a prototype GPU database at that time. So fast forward to 2017, and OmniSci and CGA entered into a collaborative agreement under an NSF program, Center for Spatio-Temporal Thinking, Computing, and Applications, which is quite a mouthful, to explore research use cases and help guide interoperability of OmniSci within the broader world of open source geospatial tools. So a problem we always ran into using OmniSci was where to run the platform. Should it be on Amazon or Azure? GPU VMs are very expensive. Should it be on the OmniSci cloud? For researchers like us, the lack of a full programmatic access to its power was a bit of a hindrance. So then we decided to explore options closer to home and looked into running it on Harvard's own big computation infrastructure, the Cannon cluster. It took a bit of messing around, but turned out to work very well. Now, suddenly, any scholar at Harvard who would like to take advantage of the computation and visualization speedups that OmniSci can provide can do so, and in the context of a rich data science environment. So an ecosystem containing 1,000 other data science tools are available here. And any scholar across more than 600 labs can spin up a machine with abundant GPU and CPU, load data sets, and analyze data for a finite amount of time. Finite. typically a week or two. These are not always on machines. They're machines you want when you need them. Get in, get out, get another when you need it. A cluster is not a cloud, and that's a good thing. Harvard's cluster and those at many universities and government labs around the world represent sets of hardware resources combined with an efficient means for sharing those resources across large organizations. Like many clusters, Harvard uses Slurm as its workload manager, but if you're interested, our scripts will be usable with minor tweaks for other clusters using other workload managers. Another big benefit of it, running it on the cluster, that's where a large portion of data science work already takes place. And a quick word on a data set that we've just loaded to the cluster, the Geotweet archive. For more information, you can go to this link, and these slides will be available later. And with that, I would like to introduce you to Raminder Singh, Manager of Data Science and Research Facilitation at Harvard Research Computing, who we've been working with on this. Take it away.
Thank you, Ben. So Ben has talked about the big data needs, especially, so I'll try to focus on the computational side of things, which like with growing need for growing big data, there is a need for computational resources. So we at Harvard have a cluster called Canon, which is like we have shared resources for different domains. FAS is a facility for arts and sciences, but the cluster we have is not limited for just core arts and sciences. We work with a lot of applied sciences and all different domains. So to fulfill that demand, we this year we acquired a new water-cooled cluster from Lenovo, so which actually expanded our capacity, and it's now listed in top 500 computers. Along with the computational needs, there are growing data storage needs. There are needs to provide GPU resources. So we have a mix of a lot of these things to serve the growing need for data analysis and to store these type of data sets and provide tools which can efficiently use to do the analysis. So to provide such services, like we look into different tools, like what is needed for efficient data transfer, then how like different tools which need to be used for data transformation, visualization. So that's where I think OmniSci fits into the offering we have. And so on the cluster itself, because it's a shared cluster, we have like more than 1,000 different software packages, all different kinds of languages. You can use all compilers. So it's a very it's a shared system to serve needs for all different kinds of research groups. But taking example of OmniSci or tools like which need a visual interface, so we are using a open source product which was developed at Ohio Supercomputing Center, and we adopted it to give access to research group for visual tools. So this is the basic interface which we have, where using your browser, you can log in, request certain amount of resources, and run the tool which is needed for the analysis. So Devika here can go into the detail how she has integrated OmniSci into the open on-demand interface.
Thank you, Raminder. Yeah, so in addition to the various data science tools which are already available on FASRC, we thought of installing two very popular database among the GIS users, and they are Postgres and OmniSci, which can be very useful for a lot of big data projects which we are currently working with. And so to do this, we have written certain set of scripts, which I will talk about later, with which we wanted to make a user interface which can make it very easy for any user to go on our cluster, and by one-click launch, they can launch both Postgres and OmniSci. And here you see a screenshot of how that is done, and later I'll try to give a live demo of trying to get OmniSci up and running on the Harvard cluster. And so this is what a user interface looks like, and it asks you for different parameters about your job of different resources. And once you specify these parameters, you click on launch, and it gets OmniSci up and running on the cluster. And this is how it looks like after it's up and running. You see the connection parameters about the details about which node it is running, which port it is running, and you can even tunnel it to your local and work from it from your local desktop. So yeah, now I'll start sharing my screen to give a live demo of how you can quickly get OmniSci up and running on a Harvard computer. So here, this is the virtual desktop interface of the Harvard cluster, which Raminder just described. And here you see the different data science tools which are already available, like the RStudio, Jupyter Lab, and so on. And the two which CGA has installed to make GIS apps more readily available to user community in Harvard are OmniSci and Postgres. So once you are logged in your FASRC account, you will see it under the other interactive apps. And to start OmniSci, you can just click on OmniSci, and and it will land you to a user form. And here you just have to mention which partition you want to run your job on. And for OmniSci, since we need the GPU resources, so we run it on the GPU partition. So FASRC has different partitions, separate for GPU resources, separate for CPU resources, and so on. So we specify the partition where a job will run, or which partition we need the resources from. Then you have to give a ballpark number for how much memory you think your resources or your computation will need, and how many CPU cores you want to use, how many GPU cores, and how much time you think you need the resources for. You can ask for up to 1 week of time, but if you think you don't need it, so then you just express that I need it for a day or two, since these are shared resources. So it's very important to have a idea of how much memory and time you will be consuming the resources for, to ensure a fair share among all the users. And then you specify the OmniSci storage directory, and then it's just a one-click launch. And this, once you launch, this will automatically do everything for you. You just get OmniSci instant installed and running for you. So you see the job is in the queue, but once it's executed, you see something like, these are my OmniSci instances, which I previously ran. And once it's running, you see the different connection parameters, that how much time is left for the instance when it was created. And you even see the string where you can connect it to your local browser. And once you tunnel to that string using your terminal, like I have done here, it will get OmniSci Immerse up and running on your Chrome browser. I have, which is like this. So it tunnels it to your local port, and then you have OmniSci running on your local port, OmniSci Immerse running on your local dashboard. This was very important for us because many of our users are non-developer and they didn't want to go into the details of using the cluster and also about installing OmniSci. And this made it very easy and user-friendly for them to just launch it with one click. So this is yeah. So then once we had this up and running, we decided to use it for our recent COVID-related analysis. And what we have been working on is to analyze the COVID-19 pandemic with the use of our Geotweet data, which we have been harvesting. And the first dashboard I would like to start with is our analysis of how the disease has spread over United States over the period of time. And on the left, you see how the disease has spread over different countries of United States. And on the right, you see the total number of cases so far, the total deaths so far, and the bottom two graphs show the trend of total cases and new cases over time and how the death trend has been over time. So the data for this graph is taken from the New York Times, and it helps us to analyze how the disease progressed in the United States. So if I filter on time, you see that in January and February, there were not many cases. But as we proceed further in time, more and more counties start showing up. And by April, almost every county in the United States had a case of COVID-19. So the interesting thing with the OmniSci Immerse is that once I filter on one graph, other graphs and figures are interactively updated. So this gives us a very good tool to analyze everything in real time. Once we got an idea of the spread of the disease, we thought that we should combine this data with our Geotweet data and see what people's attitude and sentiment have been towards the pandemic using different analysis. And the one we did is we took our Geotweet data and we wanted to analyze people's attitude towards mask, which has pretty much become an icon of this pandemic. And we wanted to see what people have been discussing about mask and how they have been discussing about it and how the attitude changed or evolved as the disease progressed in the country. So from our global Geotweet archive, we filtered on Geotweets for United States, and then we filtered on Geotweets which were having the keyword mask. And we got to about 264,000 tweets starting from January up to present. And once we have that, we ran a machine learning algorithm on it, which gave us the sentiment of the tweet. And so you see that there were predominantly negative sentiment about mask in the country over the time period over which the disease was progressing. And once I had the sentiment, I was interested in seeing that what were the emotions, what was really in those negative sentiment, what were people thinking about or wanting to say about mask. So I did an emotion analysis on the tweets, and what I saw that anger was the main emotions in these tweets, followed by anticipation, trust, and fear. So which is very much expected. And then if you see that I plotted a histogram of these tweets, and I saw that on certain days, the tweets were having a peak, and these dates were coinciding with certain event which happened on the day or a day before, or something which Trump announced in his press conference. Something happened, and there was certain spike in tweets with mask. For example, if you see on March, this is for March 12th, and that there's a peak in the tweet and spike in the tweet number with mask, and that's because on March 11th, WHO declared COVID-19 as a pandemic. So this graph helped us correlate these peaks with the different events which were happening in the world. And so if I started to play to see how how the attitude was evolving over time. And you see that in January and February, some people were talking about masks. That was mostly on the west coast and down in Florida, not so much in the east coast of US. But as the disease progressed, more and more counties, people were tweeting about masks. And by April and May, you see almost whole of United States was speaking about mask in some way or the other. So this gave us a good picture of how people were becoming more and more aware and talking more and more about mask. And we can filter even on one emotion to see how the negative sentiment tweets were distributed. And you see that a lot of it is coming from the West Coast and then down in Florida, and then from the East Coast near New York and Massachusetts area. And once you filter on negative tweets, we can even click on tweets to see what really what people were wanting to say about mask, and what was exactly in those tweets. And the other interesting thing we did is we can filter on one emotion and see the distribution of that emotion in different counties, as well as distribution of that emotion over the period of time when the disease was progressing. And also, so this distribution and space and time gave us a good understanding of how the emotions about mask were spread in the country. And to do further analysis, we can also click on the tweets to see what people were saying about what were these anger tweets all about. And then we can even filter on one county and see how the picture looked like for that county, what were people tweeting, what were the sentiment of the people, and when the spikes came in. So this was really very helpful for us to do this sort of analysis in real time. And the other thing is that then I was interested in seeing what people are actually saying about mask and why, what are these. So I made a word cloud of the tweets, and you see that the top words which we were getting from these tweets are wear, get, need, COVID, and all these things. Like more and more people were talking about the need or shortage of it, or they wanted, get it. These kind of words were there in the tweets. So then we then after we did this analysis, we thought to overlay this data with the case count across the country, and to see if there was a correlation in how the disease was progressing and how people were becoming more aware or tweeting more about mask, whether they need it or the shortages, or where the supply is actually good, and so on. So if you see that if we start in January and February, when there are not many cases, but we still see that there were tweets coming about mask. But as the disease progressed, so it's trying to update, but we see that as the disease progressed, more and more people start to talk about mask. And there was quite a correlation between how the disease was progressing in the different counties and how people in those counties were tweeting more about mask and getting more aware about the importance of mask during this pandemic. So right now it's not trying to update. I think it's so it's not updating because of, I think, some connection issues. But more or less, that was our initial step to. Yep. So I got it. So you see, as in January, there were not many cases, but still people were talking about mask, especially on the west coast of the country. But as the disease progressed in different counties, more and more counties start showing up. And also you see that how the tweets start increasing about mask in that time period. So this was our initial attempt to use this data set to do an overlap with the COVID spread. to do some sort of analysis, and we would love to hear your feedback on what else we could do with this data. Um,
Trying to get back to the slides. So
yeah,
while you're doing
I
that,
can't see.
mention.
Yeah. Ben.
Yeah, this. No, you continue to go back to the slides. I'll just mention that this this bit of analysis was just really super preliminary, playing around that we were doing. It's it really just starting to explore this data set that we suddenly have access to, and we have the right tools for using it. I'll pass it back to you, Devika.
Yeah. So yeah, this was just our initial step but personally, I feel that this data set is very powerful in terms of its overlay with the COVID analysis and how people's attitude has been varying over the course of the disease. And now I'll like to get on to the next part of the scripts which we have written to get this all automated and set up on our Harvard cluster. And below you see the link of the GitHub repository which we have made for this project. And this repository has all the scripts which you need to build this kind of interface to get OmniSci up and running on on a cluster computing kind of environment. And basically what these scripts are doing on a very high level are first we develop scripts to make this user interface for our users, where they can mention their requirement in terms of resources, partitions, and GPUs and CPUs, and they can just click on the form and get sort of started. And backend, what these scripts, when you click on launch backend, these are connecting with the Slump scheduler to schedule the jobs with the resources specified by the user. And then this, once the job is up and running, it connects with Singularity. So it takes the OmniSci Singularity container, and then it finds the port on where to run OmniSci, sets the data directory, and so on. So and in the backend, all these scripts are automated to get OmniSci and to install OmniSci and get it running. And once everything has been successfully done, our ending scripts, they pass the connection parameters back to the users, which the users can use to connect to their local port. And this was our first this was as the first step. We wanted to install OmniSci as a one-on instance, but in future, since a lot of our projects are big data, I see that distributed OmniSci will be a very good fit for most of the work we are working on, and it will make our job of scaling systems much easier. So in future, we are planning to do similar thing with distributed OmniSci, and we plan to make it automated for users to install, to get distributed OmniSci infrastructure up and running on Harvard's cluster computing environment. And now I'd like to pass on to Raminder, who will talk about how easy it is to generalize and reuse these scripts for other computing clusters. Raminder?
Yeah, sure. So Devika mentioned about few things which like Singularity and Slum. I'll just add a little bit on it. So Singularity is a container service which like similar to Docker. It's more focused to run on clusters, shared clusters like we have. because things run under user process. And it is portable. So if you have a Docker container to run run OmniSci, you can easily convert it to a Singularity container, which can be used on any cluster system you have at your institution. Talking about Slurm scripts, which are very general, like especially all these GitHub scripts are more focused on how to launch a app inside On Demand, which is another open source project which we use, which is easy to adapt for these virtual apps. Then, based on the scheduler system, you can make changes to these scripts, or if you are already using Slurm, it's easy migration to adapt this app on your HPC system or your cluster system at your institution. So I think we right now we are towards the end of the presentation, but we have a lot of time for questions or any we can go into any technical details or how the app was developed or how it can be deployed on other system.
Yeah, we don't see any questions in the question asking section. I don't know. I guess that means there aren't any questions, because I don't think it's possible for people to ask us directly through the system.
Yeah, but Ben, I think for future direction, you can talk about what other data sets you will like to explore with OmniSci, or where OmniSci can be useful for other people at Harvard or at other institutions.
Well, we do have a number of researchers who are basically, who are kicking the tires in various ways. Some are looking at large voter data sets and the influence of partisanship. That work actually started a couple years ago. It's looking as though the Geotweet data is going to be useful in that regard. We're working with a number of regional centers at Harvard who are looking at particular countries, in relation to COVID phenomena. India, for example, China, and each one of the groups has their own sets of data. Some of it's mobility data, some of it's social media data, and of course the case data. I think machine learning is going to be very interesting to apply and explore with regard to the Geotweet data set, which is very messy, but also very rich. Oh, it looks like we might have a question here. So the question is, can you access this cluster if you are based at Harvard Medical School of the Harvard School of Public Health? And the answer is yes. The cluster, FASRC, also known as the FAS cluster at Harvard, is accessible to all parts of the university, all schools, and all departments. So contact us if you have any trouble creating an account, but you can just go to the FASRC page and create an account. Anything you'd want to add to that, Raminder?
Yeah, so like especially if you have a School of Public Health, so we work very closely with School of Public Health and uh, their faculty to offer the computational support. So we already have a contract with them. Terms of HMS, especially for tools like this, which are only available on our resources. Yes, you can like in the request, you can mention that you want to use OmniSci on Canon cluster, and you will be able to give you access.
Looks like we have one more question. Can the cluster be used to process Google Street View images? Well, the answer to that is absolutely. The cluster can be used for anything, anything that requires compute resources, and for which software exists or can be written, can be processed on the cluster. Because the cluster supports a really is very well endowed with GPU resources. Large volumes of raster data, which Google Street View images are, might be there might be some opportunities to really scale and efficiently process raster collections such as Street View images.
Yeah. And on the just pen I want to add there is like we have tools like TensorFlow or other machine learning or deep learning tools available, or we have instructions how you can set it up, like we did for OmniSci. So on the cluster, we always look for tools, or we always work with the groups to set up tools which can solve a research problem.
It looks like we have another question. If I have a large data set, say global air quality measurements in grid format stored on a hard drive, can you explain the process for me to load that data into your system and how I may explore and visualize it once loaded by time location variables? So gridded data loads very nicely to OmniSci. We worked on, and last year's collaboration with OmniSci, in fact, focused around work on the national water model data set. And that data is basically large gridded data, I believe even larger in scale than the air quality data, at least the air quality data I'm familiar with. And so loading, I'm assuming this data, this air quality data is, at some regular time interval. It's daily. Those daily grid tables could be loaded as views. And then visualized in various ways according to the numeric values of the grids. I think there would be, and as long as those grids were codable on loading to OmniSci by time, interesting temporal analysis could also be applied against those numeric values in the grids. I think it's a great idea. I don't see any other questions. Anything else anybody would like to add? Well, I just have to say that we're really, really excited. As GIS, geospatial geeks, Devika and I have been loving the way in which we can manipulate large spatial data sets using OmniSci, and having bumped our heads against, trying to do this on cloud instances, which are expensive. I feel like we've suddenly been released, both to explore projects that come through CGA that might not even know they're big data projects, but also projects which are now coming in, which are coming in because people are learning about these new tools and the ability and our ability to handle large data sets. Something that traditional geospatial people, at least old school folks like me, haven't had the resources to really engage in, really just until the last few years. So we're really excited.
Yeah. And from the research computing perspective, yeah, we always look for these type of partnerships, which we have with the CGA people who are experts on these tools, who can actually bridge the gap of deploying and teaching researchers how to use these tools on the computational resources we provide, because there are, like, providing a cluster computer for research. There are we are more focused on making it more reliable, available, keeping it running all the time, and providing the right tools. But this type of partnerships are really key for giving the right solution to the people who need these.
And if our experience can be useful for other academic clusters out there, I know there are hundreds of them around the world. I'm guessing that most of them are not running OmniSci. If we can be helpful, please let us know. All our code is up on GitHub, but if you need to ping us with some questions, please do. It'll only strengthen all of the systems as we share information about optimizing these tools, and also better understanding the whole ecosystem of tools that can support platforms like OmniSci. OmniSci does certain things extremely well, but it doesn't attempt to be a Swiss Army knife. It doesn't try to do everything. And so optimizing the way in which one can get data in and out of OmniSci is also really important and really exciting for opening up opportunities for big geospatial data analysis.
Yeah, just I wanted to add to this that in addition to the script for deployment of OmniSci on the cluster computing, we also have written multiple scripts that can upload different sort of data sets automatically to OmniSci, which are also there on the GitHub repository and might be reusable for people who want to upload a similar data type to OmniSci. And in addition, FASRC provides 4 terabytes of storage for every lab and about 50 terabytes of Scratch working space, which can be used to upload data and process it on the go on the cluster itself. So if you have data on hard drive, which I saw in one of the questions, then you can easily push it up to the cluster computer, and you have a lot of storage there to store it there and to process it there.
Thank you.
And we have the tools to facilitate data transfer from your local computer to the cluster.
Yep.
And with that, I think we are just about out of time. Thank you very much, everybody. Thank you, OmniSci, and
thanks,
everybody.
everyone.
Be safe.
Yeah. Thank you.
Thank
Stay
you.
healthy.
Bye.
Thank you.